So last day we started to talk about SI units and how important SI units are. We talked about the base quantities, length, mass, time, current, and temperature, and so on, right? And we have to learn all the SI units, right? These are some of the instruments used to measure length. Remind me, I have to show you how to use the vernier caliper, how to read it, and how to read the micrometer screw gauge, right? We looked at some derived quantities like volume and force and speed and so on, right? How to get the SI unit and how to have the alternate. So for example, if you remember, force is kg ms minus 2, but it could also be written as newtons. That's okay? So you could use either one, right? Right, then we talked about errors, parallax errors, trying to avoid parallax errors to Sean. Right, we talked about zero errors and we talked about human response time. Okay. Anybody remember what this was about? 2 words. Accurate and precise. So which one there, which diagram there precise? First or second? And which is accurate? Sure. Okay, nice. Right, so we said that accuracy had to do with correct value, precision has to do with doing the right thing, right? So it has to do with consistency. And then we looked at the prefixes. And I gave you homework. I remember giving you something on pico and nano and thing, and yeah. I remember doing something like that. So pico is what? Pico, small p, what's that? 10 to the negative 12. And what was nano? Tishona, you didn't do your homework? Negative 9. Oh, yeah, you can get away there. And you had 2 more to do on top.
Yeah, because she wanted marks to work faster.
Yeah, I tell her she could go to about. We had a rotate, like now today was you.
Yeah.
Like sometimes the girl do people come or something. They kind of take the concept. Yeah, let's say.
Because you have a video, that's all.
Yeah, come here.
All right.
Right, nano is 10 to the minus 9. We had 2 more to check on top. What were they? Oh, you learned them. Do them already and you learned them. Nice, man. Very good. So we had giga and tera. Which is larger? Giga or tera? Tera. Tera is capital T, giga is capital G. Right? What was the value for giga? 10 to the 9. And tera is 10 to the 12. Okay? Let us make a note of those from the table from last week, please. Oh, for those who weren't here last week. Adding those and well, just make a note of these because I'll send them I'll send the handout with the others. Wait, you do for me? You don't know them? They're in your school? No, I don't know about it. What you could do is we did consumer arithmetic. So you can look at the video, you can bring your handphones as well, look over the video and I can do the questions of the video online. Go to the name of the school and look for the video on the last newest video. Go on live and you will see it. Capital T and capital G, uppercase, right? The first 2 on top is uppercase, 2 on it is lowercase. Not really that popular, right? But Pull this small. It's real, what's you know? You had to run stop screw to it. Or is there assemblies outside? Like, can you have some? Or just stop that? Stop it. I know what it would do. Right, nice. So you went through that, we went through that. And we talked about standard form, right? Right, the scientific method, we talked about standard form. I'll do the conversions later on, right? Actually, I can show you that now. Right? Sometimes we have to learn to convert across, right? You can convert across, yeah, you can convert across units. So for example, if I give you meters per second and I ask you to convert to something that you're a little more familiar with seeing on the highways, kilometers per hour, we have to be able to convert from one to the next. All right. So we have to be able to convert meters per second to kilometers per hour and the other way around as well. Okay, so I'll show you how to do it. Let's say we had something like this. Let's say we had 10 meters per second. I'll show you the long way first, right? What does that mean? What does 10 meters per second mean? 10 meters per second. Use a runner. So tell me what thing that mean. 10 meters in 1 second, right? Yeah. So it means that you're taking 1 second to cover 10 meters. That fast? Yeah, that fast. Right? So if I ask you now how much kilometers you will cover in 1 hour, right? We have a few ways that we can do it. First thing we can do, convert the meters to kilometers. How you do that? Divide by 1,000. So you divide by 1,000 and you will end up with 0.001 kilometers in 1 second. Are you okay with that? Now we know how much kilometers in a second. How we could work out how much kilometers in an hour? What we could do? Anybody can guess? Huh? What you could do? Very good. Find how much seconds in an hour and then multiply. So to convert to hours, what we'll do is how much seconds in an hour? Right? 60 minutes in an hour and 60 seconds in a minute. So that's 3,600, right? That's okay? 60 by 60. So we're going to multiply this by 3,600 and we'll get 1 hour here and we will get 0.01 by 3,600. How much is that? That's 1, 2, yeah. How much is that? 36? 36. So the answer is 36 kilometers per hour. Right? So in short, how do we convert from kilometers, some meters per second to kilometers per hour? All we're doing is divide by 1,000, multiply by 3,600. That's okay? Make a note of that. Convert from meters per second to kilometers per hour, divide by 1,000, multiply by 3,600. You doing it? Right. And after that, you do questions. Evelyn, are you putting it in? Huh? If you want to go across and say louder, you can do that. And just come and we'll go through problems. But today was a easy class. Yes, sir. Yes. Right? You can just multiply by 3.6. Right? Right? So the shorter shortcut is to multiply by 3.6. Okay? That's the shorter shortcut. So you have a long and short and an even shorter way. But the trick is which one will you remember? 1 month from now, which one which one you think you might remember? Which one? You remember that one? Okay. I might forget that. But what I would remember was I divide by 1,000 to convert to kilometers and multiply by 3,600. So I might remember that step. Right? That's why it's always important to know why you do something. Right? It's easier to remember why. Right. I want to complete this flow chart here. How do I go the other way around? Yeah. Divide by 3,600 and, but could you just divide by 3.6? No. Right? So you're not dividing by 3.6. So you would divide by 3,600 and multiply by 1,000. So you're doing it in reverse. That's why I prefer to try to remember that. Divide by 3,600, multiply by 3.6. Okay, so nice. So we learn how to convert, right? You know what? We could do a little speeding ticket question one time. Try this here. Everybody have the flow chart? Try the speeding ticket question, right? Anybody writing online?
Yeah.
You're writing? All right, go ahead. Huh? No, I didn't give it a somebody writing online.
So is it?
Finish? No, I didn't put the question as in. I'm now going to put the question. All right, so we have the car. Right? And the car is traveling on the highway. Well, after we're on a car. Right? And the car is traveling at a speed of 30 meters per second. Right? But the speed limit on the highway let's draw it again. The speed limit. The speed limit is 100 kilometers per hour. Right? Would the person get a ticket or not? And the police stand up right here. Right? That's the police here. Waiting on them. Right? They traveling at 30 and the speed limit is 100. Will they? Will the person get a ticket? Yes or no? Do the conversion and see, right? Person might say, no, I traveling at 30. Speed limit is 100. Right? Convert it quick and see. Right? So you want to know if it's yes or no. Right. So I have math. I have, what is it? Pure math. Unit 1, physics. Oh, look at here. This should be it. Yeah, take it. Right. That's all. So what we end up with here. So we end up with, we multiply. You can multiply by the 3.6, or you can divide by 1,000, multiply by 3,600. And we got 108 kilometers per hour. That's okay? So take it. Right? Take it for sure. Okay, nice. It's just for us to get an idea there. Are you okay online?
Yes, sir, yeah.
Okay, nice. Everybody okay with that? All right, next. So we have a little idea about that. This is a scientific method. This is more for like school, right? Anytime these are the four main steps in setting up any lab that you're going to do, right? You do your observations, and based on your observations, you make a hypothesis, and you set up your method, and then you have analysis. So for those who doing labs with me, I will do a couple of plan designs. Okay. And in the plan design, we'll be following this. Okay. You make your observations, and then you follow through these steps here. Right? The period of the pendulum, we will do that when we're doing graphs. Right. So last day I talked about graphs, right? Did I give you a graph to draw? No. Right. The only problem, though, you all have graph paper. Oh, yeah, everybody have? Well, I could share. Who do have? Let me see. Right. So I'm gonna make 1, 2, 3, 4, $10. It have a setup for one in the office. Two-sided, eh? Not a one-sided thing, two-sided graph page. So I can use it this week and next week. Just for $1. Yeah. How much need? Chances we could share. If we can't, I'll bring one from the office. Share the person next to you. We'll need at least one graph page for today. This is the most important thing that we're going to do here, because you can't run from graphs, right? You guarantee that graph question. You got one? All right. The first graph that we're going to draw, you can do it in your notebook, right? Don't waste the graph page on this one. The first one, you can do it in your notebook. Right? I'm just trying to find a way for us to do labs and they can see it online. Right? Because sometimes here we will just practice that practical something that you were doing in your lab at school. I want you to get some practice here as well. Just like one simulation or two. And I'll bring somebody up and they can simulate it. All right, ready? So what you're seeing in front of you there is what a graph should look like. Right? The only thing I do like there is they use axes, right? Normally in physics, we use a dot with a circle around it. All right. So a graph should have all of the following things here. Right. So a graph, in physics, generally, we don't use the graph as all these axes. Generally, we don't use the negative x and negative y. Generally, we use here. All right. If you need the other axes, then the question will tell you. But 90% of the time, we only use here. Right? Positive x, positive y. Right? So let's say our graph looks like that. So when you're drawing your graph on your graph paper, you don't want to waste anything. Right? You don't want to waste any space at all. So you're drawing on the outside here. Right? Don't draw your lines on the inside. Right? Draw it on the outside. Okay? So you're drawing the outside for the y, outside for the x. Right? So you have your y-axis and your x-axis. Right? The question will always tell you what's the plot. So they might say plot mass against time. Or sometimes they use the word versus. How do you know which one goes on the y and which goes on the x? Right? The one before the word against or versus always goes on the y-axis. And after always goes on the x-axis. That's okay? So you have to know which one going where. So before goes on the y, after goes on the x. Double. That's how you use it. Everybody okay with that? So your graph, first thing your graph must have is a name. After you give it a name, based on what the question told you, after the name, your next step is to label the axes. Okay? So the y-axis is mass, so you write mass. And very important, you write the SI unit. If it's kilograms, it will be kilograms. Down here, time will be in seconds. Okay? Then, hardest part. The hardest part is to get a scale. There's a formula you can use. I don't want to stress you with that as yet, but there's a method that you could also use to help you, right? On your scale now, when you're designing your scale has to give you a graph that is more than 2/3 of a page, right? So if you look back at this one here, you see that line? That line went to more than 2/3 of the page. You're seeing that? The red line? You don't want your graph to start and stop right there. Or you don't want it to start and stop there. The graph has to go to, some people will say more than half, but 2/3 is the best thing, right? At least 2/3 of a page. Pick up your whole page, perfect. Right? Everybody okay with that? So your scale has to be designed so that your last value is like all the way here. Your last value is like all the way here. More than 2/3 of a page. Question? No? Right? So your graph has to be more than 2/3 of your page. So your largest value for the x, this is your largest x value, has to be around the end there. And this is your largest y value. Right? So you have your largest x and your largest y value. Yeah, everybody okay there? Nice. When you're creating your scale, I'll show you in your first example. Right? You put your little lines here for every 1 centimeter mark. And there are some increments that you can go in. The first increment is the obvious one. Right? But if that gives you if that doesn't take care of the largest value, you go to 2, then to 4, then to 5, 10, and then so on and so on. Okay, these are the values I want you to learn to use. Do not use trees, right? Like 3 and 6 something, a multiple of 3. That's kind of harder to read off. Possible to read off, but it's harder, right? So you go in 1s, then 2s, 4s, 5, and 10s. Okay. Sometimes you gotta go 20, but don't go in multiples of 3. Try to avoid that, right? Multiples of 3 is much, much harder to read off the points. Next thing, when you plot, you put a dot where the X and Y value come on, and you put a circle around it. Dot. Okay. So you draw a nice light dot, don't color the dot, don't draw a big circle. Right? And your pencil should always be sharpened or invest in a mechanical pencil. If you can't afford a mechanical pencil, wait till school over, walk through some classrooms, and you must get one, guaranteed. You must get a mechanical pencil, especially in the Form 1 classrooms. If you see a pencil kit, you could go in it. If there are more than one, you can borrow one, right? Right, but you must find one. Just walk around and you'll get a mechanical. If you have a normal pencil, make sure it's sharpened, right? Because you don't want to color and make a big dot, because that'll pick up more than 1 point. Okay, and it's a little more difficult when again your best fit line after. Right now, the next thing that we have to learn to do is to draw a line that will represent all the points that you plotted. That line is called a best fit line. So write this down. Best fit line. Right? The best fit line is drawn. Best fit line is drawn. Best fit line is drawn so that it is equally close to all of the plotted points. Best fit line is drawn so that it is equally close to all of the plotted points. I'm going to show you a couple of examples here. Right, those who are online, you'll get us click on the camera, right? And you'll see me on the whiteboard. This one is right. One line should go through all of them. Okay. Right. Remember, you're not connecting it to dots. You're drawing one straight line. Okay. Ideally, try to invest in a long clear ruler so you can see through to the points if you need it. Right. So a nice long clear ruler. Long. Right. Right, so you need a nice long ruler. So that's example 1. Example 2, suppose you have something like this. Right? Something like this. Look how these points face out. Right? Yeah. So you have to draw one line that's equally close to all these points. Right? So let me just give you a wrong one first. So if you try to go here, it went through 2 points, right? But it's far from these. So your line has to give you a picture that your points are painted. Okay? Where else we could go? Right? So what we could do is something like this. right? This one a little bit far, so we had to go. Let's come down a little bit, right? Exactly. Now go. Right, so I can probably go right here. It equally close to all of them. It went through these points, so that's good. And it equal distance from these 2 points. That's okay. There are also times. There are also times when this might happen. Right? This one here will not pass through the origin. You're seeing that? It will not pass through the origin. So you're trying to get it close to all of them and pass through as much as you could. So here, equally close here, and it passed through a few. So you're good to go. You okay with that? So these are best fit lines. Everybody okay with that? So it has to be equally close to all, and if you can pass through some, that's good. Right? But notice it doesn't have to go to the original time. Make a note of those best fit lines, right? So you should be able to rub off all the points I have got, and that line should give you a good description of what you would have gotten. Okay. Tell me what you all think about number 4. Think about number 4. If you're in your lab, I can then somebody come and see what they're first. And that happens. What will you do? If you're in your lab, good, but you want to shake up the table. That happens. What you going to do after you hit them? Right? Because and you have these 5 results. What you gonna do? Any ideas? So all of them like this, 4 like this, and 1 down here. Huh? Very good. Right? You exclude this. So if you plot something, right, and everything perfect here, like 90% of them here, and you have this one outlier. It's called a outlier. You don't want to create a best fit line here, right? Because that's wrong, right? Because all these here lining up perfectly in this line. Right? And so as a physicist, you'll have to say you're ignoring this and why. Right? You ignore this point because Frankie come and shake up the table and show up the timer. Right? So you have to be able to identify these things. Outliers could happen. Okay, I don't want to say will happen, but it could happen. Okay, very good. All right, so your best fit line will stay here and you ignore that outlier. Online, you're seeing, right? You just click on the camera icon. I think you should be seeing it. Right?
Yes, yeah, we see him.
Right. So draw those 4 there from up, please. Tina here, Jenna, Ramjan, or your online last week. After your best fit line, that time period. That makes up heading video. And so we have best fit line. Hopefully we understand that best fit line. Okay, everybody can plot, right? Everybody can plot, right? If I give you 4, 5, you look for the X and the Y and where they meet, right? Plot it, right? Okay. When you're plotting, right, there's something I want you to always know. So if from here 0 to here is 20, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 small blocks here, you should always know what one block represents. Okay? So if you have 10 small blocks, you take 20 and divide by 10. So you know that every one of these shows 2. You have to know that. Okay? So when you're reading off points or trying to plot points, you know, okay, this is 2, so in between here is 1. So if I have to plot 19, I'm looking for 18 and in between. Okay? Always know when you're plotting what one small block represents. On your graph paper, you have 1 centimeter blocks, and every 1 centimeter block you have 5 small increments. Okay, make sure you know what each one of those small ones represent. Nice. So we know that. So on this diagram here, I would have a best fit line. Right, my best fit line would be about there, equally close to all the points. Okay, last thing, gradient, right? I want to talk to you about gradient, that you should be able to watch a line and say, okay, that gradient is positive, negative, 0, or have an idea of where it is, right? When you're working out your gradient, what you're saying, right? You pick 2 points on the line. Do not pick points that are plotted, because there's a chance that this point, although it's looking like it's on the line, it's not on the line. Okay, so don't choose those points. Pick a point on the line here, on the line here. Can't choose them far apart, right? Choose two nice points on the line, connect them by a large triangle. Right? This point will be x2, y2. This point down here will be x1, y1. And then you find gradient. Gradient is equal to y2 minus y1, x2 minus x1. Okay? So your completed graph should look like what you have on top there. Right? Just picks up your graph, and I want to give you a note on gradients. Go back to the page and pick up your graph. And then head up gradient. Just go back and pick up your graph there. It did not happen. Chess, right? We don't know how to play it up with you that I could play and they'll teach you. All right. What are we doing again? Gradient, very good. All right, so let's take a look at a quick little note on gradient because you'll have to be able to understand the concept of gradient. What does gradient mean again? S word. Gradient or what? S word. What's the S word? Slope. Slope. Gradient or slope. So you will see in past papers, it asks you to find the slope. Okay. So what does gradient represent? As I said, gradient represents the slope. The symbol is lowercase m. All right. So if you look here, look at this line. Does that line have any slope? Nope. So the gradient there is 0. All right. What about this line? How much slope does this line have? All the possible slope, right? So that gradient is infinity. You all okay with that? This here is said to have a positive gradient. And this here is a negative gradient. Okay, so by just watching the lines, you should know, okay, when I work this out, I'm supposed to get a positive gradient. Or when I work it out, I'll get a negative gradient. All right. All right. One more thing that we can learn from, right? Oh, by the way, gradient is equal to the change in the y2 minus y1 over x2 minus x1. You ever did the rise and run method? Rise over run. Okay. I'll show you that one day, right? Measure the rise over the run. Finish? You got the questions too? Give us some more, boy. Give us some more, you good. Give us some more. Here, I'll give you. But if you follow the compound interest and depreciation, all right, you can stop. I don't have the book that's it. So you escape. So that means an hour and a half. That's like a finish in an hour. You're okay with that? Right? One more thing that the gradient gives you, right? Remember I told you, Tishan. Remember I told you that every time you write a quantity, like length, it has a SI unit. Right? Most of the time, gradients also have SI units. Right? Just check it to make sure. So if I give you a graph and the graph is mass in kilograms versus time in seconds, right? The gradient of that graph, after you work it out, that gradient is what? Positive or negative? Positive. That gradient will have some value and unit. how do you work out that unit? Right? Real simple. The unit is always the unit on the y divided by the unit on the x. Okay, so in our example is what? In our example is kg per second. Okay, kilograms on the y, time on the seconds on the x-axis, y-axis. Okay. Right. Pandina in the back, Chloe here, Nathan reached back, Aidan, right? Aidan, Annalie, who's Annalie. Right. Annalie, you move from there. You won't say down there? Just in the back. Okay, no. Next Annalie. Rekaya. No, Rekaya. Oh, Rekaya was a girl. Shivanan. Adam. Next Annalie. Tishon. Alexandria. Chanel. Henry. Attilia, they're not here. Tagram here. Karina here. Anya here. Anzari. I know who's that. Anzari. The boy. Caleb online. Christian online. And Gianna here. Who didn't hear the name? 1, 2, 3, 4. You just add the name to this list here, right? Your name and contact number. Try and one right here, right? Right, so always remember that the SI unit for a gradient is the unit on the y-axis divided by the unit on the x-axis. Every gradient, once it has a unit, you have to write it. Okay? Right, can we do a plot boy in 15 minutes? Yeah. I feel we can do it. We can fix it, but just your number for now. I'll ask you email afterwards. Last thing, and we done. So here's what we're going to try to do, right? We're going to try to plot a graph of t squared versus L. Okay, these are your t squared values, and these are your L values in the beginning. So just do me a favor, don't write the whole table, right? Just write the length values, these values here, 0.1, 0.2, 0.3, 0.4, 0.5. Oh wait, 0.5, 0.6, no 0.4, and write these values here. And we're going to develop a scale, and I can let you plot it for homework. But I want to do the hardest part, the scale. Okay? So write down those values, please. Length and t squared. Okay. The length and t squared values, do not write down it two in the middle. We got time. We have a question. Right, so we have that's enough. No, yeah, it's all good. So good. Ready? Right, only the length and t squared values, right? And I want to show you how to create that scale on your graph. Right, so the length is 0.1, 0.2, 0.3, 0.5, 0.60, right? And then we'll talk about significant figures next week, right? Why it is everything is the same significant figures. And then write down the t-squared values, right? So when you finish, here's what you're doing from now. Put the name of the graph, draw your line for your y and your x-axis. Right? And let's see if we can figure out the scale for the x-axis first, then the y-axis. Right, so draw your lines on the x and the y. Right, put the name. Put the name, and let's see if we can figure out the scale. Right, draw your line, say x, and then count how many 1 centimeter blocks on the x-axis. Let's see if we can figure out what scale will do. Ready? So on your x-axis, we have to figure out what scale what we're going to use, right? This kind of straightforward because you're seeing the increments 0.1, 0.2, 0.3, 0.4, right? So we have to figure out every 1 centimeter how much we're going, or every 2 centimeters how much we're going. All right. So let me probably try to use what they have here. So on your graph, start with 2 centimeters. Also start at 1 centimeter. Don't write anything. So what you're doing from now? How much 1 centimeter blocks have? 16? 17? Okay. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 17, right? That's okay? Good. So let's start. Don't write. You can just count it mentally, right? 0.1, 0.2, 0.3, 0.4, 0.5. The largest value was what? 0.6, right? That pick up less than half a graph, right? So we could double it. Instead of every 1 centimeter, we could go every 2 centimeters. So here we 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Right? That's the manual way to do it. Okay with that? So on the x-axis, every 2 centimeters is 0.1 on the x-axis. 0.1. Anybody confused? I'll show you all the formula next week, right? But some people do like the formula. 2 centimeters is 0.1. After you do that, Take a look at the largest value on the y-axis. See what possible scale we can use. Largest value is what? 2.43. We have to figure out what scale we can use. Try 0.1. Don't write, just count and see if 0.1 will fit. So go 0.1, 0.2, 0.3 and see if it will fit. If that doesn't work, we had increase, right? Anybody confused with the y-axis? Count your number, block, right? The largest value is 2.43. So you have to figure out a scale that will work. We do the manual way today. Okay? So start with 1 centimeter, be like 0.2 or something. If it doesn't fit, change to 0.4. Right? If not, try 0.5. Did 0.1 work? 0.1, 0.2, 0.3. Did that work? That would work, right? So we had to double up now. Try 0.2. That doesn't work. Try 0.4, 0.5. One of those should work. Too confused.
So you could show us like a finished product. Are we done? So excuse.
Every 1 centimeter is 0.2. And go all the way up. So the middle of the axis. So say that's going. So what is it? Right? For those who are a little confused, right? Remember, we're trying to reach 2.43, right? So the manual method is we have to actually go through and see which one will work. Right? Again, I'll show you the formula method next week. So the problem is if we were to try 0.1, 0.2, 0.3, 0.4, and you go all the way up, you reach 2.4. Can we write down 2.43? No. So although that looks perfect, we can't use 0.1 for 1 centimeter. You would have to use 0.2. Okay, so every 1 centimeter is 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, and it has go until you reach 2.6. Okay, all right. And once you reach there, you'll stop there and you'll start go over from 30.2. Got it here now? Thank you. A little bit low, I'll show you the formula. Right. Formula method, you have to- Right? We'll do it the one next one, like a 10.5 is one to start with. Right, but they will work, I want to plot that, plot the x and y value. Plot it and triangle up that line, then you can do gradient, go right there. All right, so for your homework, plot the point, straight line, and if you do gradient, go right there, right? Go ahead, and we'll do our next graph, we'll walk the graph for next thing. We have a couple of graphs to do next. Can be about 2 or 3 graphs. Yeah. So, like my item. It's not perfect, but it's still not the half graph. Okay, not perfect, but very important. If it was like 2.38 or something with the largest value, that would have been real good. All right, so that's it. Right, graph drawing, the hardest thing in graph drawing is we gotta get a scale right. Okay, so if you like the mechanical method, go right ahead. If you like the formula, but that scale is the hardest thing. Okay, so for homework, start it from now, find the gradient. Then we can jump into some physics stuff, right? Match. Okay, so that's it. Online, your